Alright, the next one is going to be now solving system of equations involving word problems. So we can either use substitution, elimination, or graphing. So here the first problem is James' school is selling tickets to a spring musical. On the first day of ticket sales, the school sold 3 senior citizen tickets and 9 child tickets for a total of $75. The school took in $67 on the second day by selling 8 senior citizen tickets and 5 child tickets. What is the price for 1 senior citizen ticket and the price for 1 child ticket? So we would come up with 2 equations that we would have to write, and then we would have to solve it. So let's go ahead and write the first equation, which is the amount of sales that they sold on the first day. So on the first day of ticket sales, the school sold 3 senior citizen tickets. So we can say X is for senior citizen, because we don't know how many tickets they sold. I mean, how much each ticket cost, sorry. And then 9 child tickets for a total of 75. So that would be my Y. My child would be Y. So my senior would be X, my child would be Y. So then if I were to write an equation, I would write down 3x, however much the ticket costs, which we don't know, which is what we're trying to find. So 3 senior citizen tickets times the cost of each ticket, plus the 9 child tickets times the cost of each child ticket, ends up equaling to $75. That would be my first equation, because I don't know how much each ticket costs. So then now the second equation, the school sold $67 on the second day by selling 8 senior citizen tickets and 5 child tickets. Senior citizen is your X, child is your Y. Same thing as we did earlier. So then I would write 8x, because we don't know how much each ticket costs, plus 5y equals 67. So we have 2 equations. We can either graph them and see if they intersect, or we can do substitution or elimination. So the first one I'm going to use is substitution. In order for substitution to work, you need to have a y by itself or an x by itself. So we need to make it that way. So in this case, I would like to use the first equation because they are all divisible by 3. So that means that they can all divide by 3. So if I'm going to divide everything by 3, I want 3x at the end. So we're going to be solving for x. So we're going to get rid of that. So I'm going to rewrite it. I'm going to put my little arrows so that you know I'm rewriting it. We want to solve for x, so we're going to subtract the 9y, move it over to the other side. So I have 3x equals negative 9y plus 75. We are going to divide by 3 because we want x by itself. So I have x equals negative 9 divided by 3 is negative 3y. 75 divided by 3 is 25. So my first equation was rewritten to that. So that's my first equation. I just rewrote it. It's just written differently, but it's the same exact thing. This is equal to that. So now that you have a variable by itself, you can do substitution. So we're going to plug this part in. This is the first equation. This top one is that. We're going to plug this in for the x on the second one. So this part is going to go in for the x on the second equation. So I have now 8 parentheses, which is what we're going to plug in right now, plus 5y equals 67. This is your x, which is what we just found right here. That's what's going to be substituted in for the x. Negative 3y plus 25. So then now we do the distributive property and we solve for y. So distributive property here, that's negative 24y. 8 times 25 is 200. Combine like terms. That is negative 24 plus 5. Well, in this case, because they're different signs, you're going to subtract. So it's 19, but it's negative 19 because the 24 is bigger. Negative 19y. And then we subtract 200 because we want y by itself. We're solving for y. And there we're going to subtract because the 200 is a negative and the 67 is a positive. So it ends up being negative 133 because the 200 is bigger. So you keep the sign as larger. Almost done. Divided by negative 19 because we want y by itself. Negative divided by a negative is going to be a positive number. And we divide the numbers and it's positive 7. So what did we just find? We found what y is. Y stands for, what did we say y stood for? The price of the child ticket. So that means each child ticket costs $7. That's for the child. Each ticket. For one ticket, it is $7. So we want to find how much a senior citizen ticket costs. Well, remember that one that we rearranged at the beginning? This one right here? Well, we can plug in that 7 into here for the y. So then I have negative 3 times 7 plus 25 to find what x equals. Negative 3 times 7 is negative 21. Negative 21 plus 25 is 4. X equals 4. $4. So what does the X stand for? Well, the Y stood for the child ticket. The X stands for the senior citizen ticket. So that means every senior citizen ticket costs $4. And there you go. Let me zoom out so that you can see all the steps. This is called substitution because we substituted x into the other equation. FYI, we could have put this 7 into here for the y and then solve for x, or we could have put it here as well and solve for x. Either way, we were going to get the answer as being 4. I just plugged it into this one because it's a lot quicker. But remember, this one's the same thing as the first equation. It's just rewritten differently. I'm going to solve this same equation, this same problem using elimination in the next video.